Hello, here I'm going to give a presentation on my project on CSCIE 89 deep learning. The project is about facial recognition with images of Nepalese celebrities. Here I'm comparing the performance of 6 pre-trained models I made, and then check if they have any problem because my data sets are small, and I'm also trying to improve the performance of those methods by using neural style transform. And this page summarizes the whole process of the facial recognition. The first step is to obtain the images. Once I have the images, then because my image sets are very small, then I did the neural style transform. I use 4 style images to do the neural style transform. And this is actually I have done only for the training images. When the training images are neural transformed by 4 style images, actually the number of images increases to 5 times. And those all images are collected together, and these 10 images are used for training the models. Once the models are trained, then I have to test these models. To test the models, I need the images which are not exposed to the models. And I have those images which are categorized as testing. I use those testing images to test whether those methods can recognize the images of the celebrities. In this way, I develop the method and test the method. Here, this is the code used to inspect the data images. Especially, I started with inspecting my full data set. I'm using this algorithm to count whether how many images are there, how many images of the persons are there, each person has how many images, what is the size of the images, whether they have the square size or different size, something like that. And here is how I use that code to inspect the full data set. And based on this algorithm, there are like 1612 images, which is correct, and the number of images per person is given in the photo count column. You can see, as per example, the Sandeep Chhetri, there are 31 images for that person. And I also check the sizes, and I also manually go in the folder and check whether these numbers are correct, and these are consistent. And so I have 1612 images in total. I also found that there is another split files method developed by somebody which is very handy to do this kind of splitting. And after splitting the data, I use that count method to inspect how many numbers of images are there. The total number of training images are just 1100. So see, my train images are only 1100. Facial recognition with just 1100 is going to be very bad. So I will try. I want to do increase the at least 4 times. So I use the method called neural style transform to augment the data so that number of images could be increased depending on how many style images are produced. And after style images are produced, and this is the algorithm I wrote to display those images in grid. To apply the styles, I chose 4 styles. So 3 styles, they are hoodie cartoon styles, and one is blockhead style. I use those 4 styles to do the neural style transform. When the neural style transform is used, then the images are changed to some different colors or different the textures, something like that, depending on what is the style you use. Here is the examples of photographs how the photograph changes when I do the neural transform. In this photo, you see the first photo in these two pictures is the original photo, and these four other images from left to right, they are style transform images. You see how the colors and textures of the images are different from the original image. This way, I can increase the diversity of training images. And this is the another person, the Rajesh Hamal, one of the actors in Nepal. So here, if you see the first image, which is the original image, is different from the star image. The star image has different texture and different color depending on which style you applied. And if you see the styles, the image of the styles depends on what is the the content picture as well. Further improve the method, I have to use the other kinds of augmentation method. The other augmentation method is like the images can be rotated to give different angles. And image can be shift, they can be give a shear, and then they can zoom, they can do the horizontal flipping. This way I can artificially produce augmentation in data. This kind of augmentation can be done in Fly by using the image data generator process in Keras. And see, in this case, I did the augmentation only for the trained data, but I have to rescale all of the data, like the validation data, test data. It has to be rescaled to between 0 to 1. Therefore, all the pixels are divided by 255. So I also do the dropout and batch normalization for these all method testings. And actually the methods are tested since I have two kinds of data. One is without NST, without neural transfer, and another with neural transfer. So I'm going to develop two sets of methods. One set of method I'm going to see whether the NST improves the method or not. By comparing these two, I can see whether the NST improves. After construction of this model, the model has to be compiled. Here I compiled the model and use the Adam optimizer. And since the classification problem, the loss function is categorical cross entropy, and I use the matrix accuracy and summarize them. After the model is compiled, so they are ready to train. So fit method is used to train the models. So while training, I set up checkpoint, early stopping, and reduce learning rate callbacks to improve the problem due to overfitting, and save the trained parameters in the parameter history parameters, which can be retrieved and can be plotted. But in this case, I write a method which I called train with callbacks. This method train the methods on the models with train images, and then after training the model, it uses the test images and test the models and print out the result in the function in the form of plots and also confusion matrix as well. So I also developed the methods. I also trained the models from the NST. Therefore, now I have 12 models, 6 models trained with data without NST and 6 models trained with data without NST. And now I have all the trained models, and then I'm going to see how they. So here, this is VGG based model. The top one is the model without NST, and bottom one is the model with NST. And see, the bottom one has almost 30% validation accuracy, while the top one has about 25% validation accuracy. This shows that NST improves the validation accuracy by 5%. And this is another method. Here in this method, both NST and without NST have almost very poor validation accuracy, as low as 5%. And this is the model built on the third pre-trained model. In this case also, NST data and without NST data, they have very poor performance, and performance is as low as 5%. And next one, here also the performance is very poor. It's also as low as 5% validation accuracy. The next one is still very bad, like about 3%, whether it is NST or without. So I found that the VGG19 method gives the better performance than rest of the method. Even though the VGG19 gives the better performance, it's performed poorly because its performance, the validation performance is just like 30%. And all other methods, they perform very poorly. However, in the case of VGG19, I found that the use of NST improves the validation accuracy by about 5%. That indicates the model performance can be improved by 5% using NST. So